This is part 2 of lesson 3.1 on proportional relationships. We're going to focus on graphs, but first, a warning, you must have completed the video on tables before beginning this, as we'll be incorporating that skill into this lesson as well. So the first thing is you're going to need to copy the coordinates from the graph, and the coordinates go in alphabetical order, so x, then y. X is always the bottom of the graph, so it runs left to right. And then y, I always remember y to the sky because it's the line that goes up and down. So you do x first and then the y. After you copy the coordinates from the graph into an XY table, also known as an input-output table, you're going to repeat the process that we did in the first video for finding k. So you're going to look for patterns with the x values, look for patterns with the y values, and if you can't do that, you're going to find the unit rate of each of the coordinates, which should be the same, because in order to be proportional, they have to be the same. And then after you find k, you're going to plug it into the equation y equals k times x, just replacing k, and then all of the coordinates should work for the x and y value to make a true equation. So we're going to start with our first example. So we have this graph, and I went ahead and labeled the x and the y for you. Again, x is going to run left and right, and y goes up and down. Again, y to the sky. So our first coordinate is actually going through the origin 0, 0. So our x is 0, and our y is 0. That one's really easy. Then the second coordinate, you go over 2 on the x. So the x value is 2. And then we're going up to 4. So the y value is 4. Then the next coordinate, we start at the origin, go over 4. So that's our x value. And then we go up to 8. The next one, we go up to the origin, go over 6, up 12. So we have 6, 12. And the last one, we start at the origin, go along the x-axis, and we go up to 16. So it's 8, 16. So again, all of our coordinates you're going to see make up each individual column. So we have 1, 2, 3, 4, 5 total. Okay, so now that we have our table filled out with our coordinates, we're going to look for patterns with our x's and then our y's. So x, 0 and 2, we're adding 2. And from 2 to 4, we're adding 2. From 4 to 6, we're adding 2. And from 6 to 8, we're adding 2. So far, so good. It looks proportional, and I can kind of tell it's proportional because, again, this line is going through the origin, and it's perfectly straight. And then we're going to do the y's. So y, 0 to 4 is plus 4. 4 to 8 is plus 4. 8 to 12 is plus 4, and 12 to 16 is plus 4. So it is consistent. So what I can go ahead and do is I can skip that unit rate step if I wanted. If not, I'm going to do 4 divided by 2, 8 divided by 4, 12 divided by 6, and 16 divided by 8, which I can tell you is all going to be equal to 2. So I know that it's a proportion. I'm going to jump ahead and figure out k. So the formula for k is y divided by x. And since they're all consistent, I'm actually going to use the pattern. The pattern with y was that they're all 4. So we'll put 4 in for the y. And for x, they were all 2s. So I'm going to put 2. 4 divided by 2 is going to be 2. So k equals 2. And then if I wanted to write an equation, y equals k times x, I'm going to plug in 2 for k. So y equals 2x. And I'm actually going to erase some of this so we could check to make sure this is going to work. All right, to check our work, we are going to take a y and x value. I'm going to use 4 and 2. So 4 will be our y, equals 2, which is k, times 2. And that's true because 2 times 2 is 4. And then I check one more. I'm going to actually go to another part on the table. We'll use 6 and 12. So 12 is x, or sorry, excuse me, 12 is y, equals 2 times x, which is 6. So 6 times 2 is 12. So I have the correct equation for that table. All right, one more example.